Get Certified Together program is created by Technocofe, your free online knowledge sharing website, based out in London.
Is duly checked. No one is bringing their partners or their vendors without permission, and there are due checks related to like who is going in and out, what kind of biometric mechanism we can put in place on the rack entries. You should avoid using keys for everything. You should have some kind of biometric mechanism to authenticate who is going in and out. Beside physical protection, of course, you need some kind of environmental protection as well. So all kind of fire extinguisher or kind of Hey everyone, welcome to episode number 34 of the Get Certified Together series. I am recording my last episode from this house, as I told you in the last episode that I'll be changing the house soon. So I have most of the things packed up already and I have limited stuff with me to perform this recording. That's why maybe you will have slightly lesser quality, or maybe you will find some kind of disturbance in between, but still I do wanted to cover something for this week because we might be having a 2 or 3 weeks of delay when I'll be moving out and I have all the things packed up again. I wanted to share with you about a couple of things related to CCSP itself. I have covered some topics, I have learned some topics, and beside that I had finally created ISC Square membership account last week. So if time permits, I'll give you some kind of, or even in the beginning of episode, I'll give you some kind of introduction how you guys can do that yourself. You can be member of ISC Square. We covered this long back when we had a guest in our one of the episode, but anyhow, I'll cover it again because I have done it last week only. So I have a kind of a fresh memory of how I did that. So you can get an idea as well. Also in July and I have my KCNA exam, which I told you. So I have to work on Kubernetes and cloud native things. I have almost covered all the topics of KCNA and it's actually quite straightforward and simple, but if you are new to this field, then of course it might be complicated. Most of the terms are our day-to-day terms which we hear in all the other podcasts or all the other technical blogs. They are already covered, like observability, how you can make sure that your application is resilient, and how you can deploy it in kind of like a auto scaling group, so you cannot have any kind of disturbance, any kind of downtime when your application is overloaded with the utilization. So most of the things are day-to-day terms which we hear in the similar kind of field if you are working in the similar kind of field. So it's not that complicated, but I will not say it's quite easy till I have given exam, because I don't want to be in a situation where I say that this exam is quite straightforward and quite easy and then I fail in it. So just bear with me for another 3 weeks. I'll give that exam and I can give a better idea to you guys if you want to do KCNA associate exam. So that's for the KCNA thing. Alright, let me quickly give you guys an idea about how to be an ISC Square member. So if you go into the website, which is in the show notes, if you go into that website, you can register yourself as a user and you can create your own account. Just bear in mind, creating an account don't make you a ISC Square associate member. To be a member, you have to first showcase an interest in a particular certification. For example, if you choose CCSP, CISSP, anything at all, you can choose any certification based on your current skills and based on what you really want to learn. For that, you have to go in, register as a member, and then find a certification path. So you will get I think 3 or 4 questionnaires based on what kind of requirements you have, what kind of skills you have currently, and what you intend to do with the certification. On the website itself, you will receive some kind of recommendation which certification you want to choose. Just select CCSP if you are into CCSP, and they will give you another form on the website itself where they will ask a whole bunch of details about what kind of job you are doing, where you are located at, and are you already a member of ISC Square, all those basic things. And once you fill in everything, you will get a membership ID. So that is actually the actual membership ID. Any kind of certification you will do in future will be associated with that membership ID, and that kind of like a proof which you can show to anyone that I am a member of IC Square, and based on that membership ID, your future organization or anyone can check what kind of certifications you hold. So that's kind of like your license to show that you are an authenticated guy and you have all the certifications with you. Of course, being a member is not enough. You can be you must be a member of your local chapter as well. So ISC Square have a lot of local chapters, and you can be a member of one of those. What they will do is they have this weekly or monthly events or knowledge sharing session. They have a lot of resources with them as well. A lot of people who are already certified will be part of that chapter, and it's kind of like a community. You can go attend their events, and it will help in getting insight on how you should be preparing, what's your idea about cybersecurity or info security, and what things you're lacking, how you can improve those skills. So it will help a lot. I myself, because I'm now moving from one place to another, the new place where I'm going, I already emailed them that I'll be coming there, and I want to be a local member of that chapter because I'm shifting to their place, and they have already approved my request. So I'll be becoming a member of local Thames Valley chapter. Something similar you can do in your place as well. There must be a lot. ISC Square is kind of like a worldwide organization, so you will be finding something nearby to your place. If not, then anyhow, it's not something like it's kind of mandatory thing, but if it's not there, then I don't think there is any harm. You can continue doing your good part, you can continue doing your learning bit, and all other things will fall into place. So don't worry about like joining or becoming a member of a chapter is kind of like a thing you must be doing. It's not blocking anything from you. If it's there, then it's good to have. If it's not, then it's all right, you can still do it. All right, before moving into the main episode, let's take a quick break, and after the break we'll be having a quick recap of what we did last time. All right, thanks for coming back. And for the quick recap, what we are doing in domain 3, we are covering cloud infra security. So by now we have, in fact, let me give you a quick recap what we have done till now from domain 1 to domain 2 and now in domain 3. So in domain 1, we have already covered about cloud building blocks, what kind of building blocks are associated with the cloud. And by now, if you are following all the episodes, you might have seen this trend that whatever we have covered in domain 1, they gave us a good overview of what kind of topics are expected in further domain 3 and so on. So we covered a bit of data security, we covered a bit of infra security, risk associated and everything in the domain 1. When we moved to domain 2, we covered a more advanced discussion on data security. So we covered secure data lifecycle, various kind of strategies to make sure your data is always secure, and of course solutions like data loss prevention system, and how you can monitor your data, how you can make sure that all the events which are happening inside a database or happening inside the system, all the information going in and out of your organization, how you can monitor those, how you can keep track of everything. So that's all. And of course, a lot of things related to data was covered in domain 2. In domain 3, now we are covering more towards cloud infra security itself. So various layers of cloud infrastructure, a data center, if it's private on-prem or if it's on public cloud, what kind of building blocks will be there again. And then on each layer, on each building blocks, what kind of risks are associated. Now, till this episode, we have already covered what kind of risks are associated. In today's episode, we will be covering more towards what kind of security mechanism or what kind of strategies we can put in place to mitigate those risks, or to help any organization overcome those risks which are associated with individual layer. Because if you remember, cloud is actually based on multi-layer architecture. So you have a base physical infrastructure. On top of that, you have hypervisor or some kind of operating system. On top of that operating system, you will be actually installing your virtual machines or containers. And on top of that virtual machine, your applications will be running. So it's kind of like a multi-layer architecture, and one of those layer will have its own associated risk. So we'll be covering them one by one in today's episode. Now let's start with the bottommost layer, which is physical layer. By physical layer, I mean your actual data center, your actual servers, hardware, which you are putting in place or your organization are keeping it, running them, and if you are a if you are using cloud hosted services, if you are using a cloud service provider, AWS or Azure, you might not be seeing them with your own eyes, but again, those things are still there. Even if you are not the owner of them, AWS or Azure are the owner of those physical data centers or those physical locations. So anyhow, someone must have to take care of those strategies. If it's your responsibility in case it's private cloud, or if it's CSP's responsibility if it's a public cloud. But those to be considered, and those are kind of like standard. So you cannot ignore them, or you cannot modify, or you cannot tweak them according to your need. You need to make sure that they are in place as well. Now, first and foremost, location of your data center, where your data center is located. Now, just understand, you can put your data center anywhere across the world. No one is stopping you. You just have to lease a land. You may need to buy a land and just make the building or lease a building and put your server, put your racks there. But location of data center is quite important, because where you are putting your data center directly impact the life of that data center. So if you are putting it in place where you have kind of like environmental threats, like maybe a high tide, or maybe regular cyclones, or bad weather, or even if it's quite hot and dry weather but really hot, then you need to buy a lot of cooling system for your data center to make those servers up and running. So location of the data center is really important, and of course it's important in terms of creating a standby site as well. Even if you find out a good location and you finally decided to put your data center or put your servers there, you need to then decide on standby location. Now that standby location of course should be geographically far from your actual location. If you are in a smaller country, if in a city itself you want 2 or 3 locations, maybe you have high requirement, maybe some kind of requirement which want you to keep 2 or 3 data centers almost co-located, still they must be at least 15 to 20 kilometers apart. Any kind of level of geographical redundancy can only be achieved if you have some distance between the 2 locations. Otherwise it doesn't make sense of putting another data center in a place where you have already one up and running. So location of data center is really important, and someone must be deciding on all these things. There must be a budget allocated, and there must be a top management sitting and approving all the budgets associated with where those data centers should be located and what kind of investment organization want to put in. Those criteria may be related to what kind of standby system you want to build in. Just remember, we discussed a lot about hot standby, warm or cold standby site. So all of these things drive a lot in terms of they increase the cost if you are going really about like active site, and your organization may or may not have this much amount of money. So of course they might want an active standby site, where standby site is just cold, it's there but it's not running, and if something goes wrong, someone have to build that site up, that standby site up as well. So it depends on the budget of the organization as well. But again, you cannot compromise a lot on those things. You cannot really sit and say your management comes up and tell you that because we don't have money, we cannot let you build a standby site. This really doesn't work in that way. Even if you have budget constraint, you have to build some kind of strategies you're around that budget, but something should be there, and that something is a standby site on multiple locations, and those locations must be discussed and strategized. You cannot just randomly find a spot on the globe and just build your data center there. Now once that facility is up and running, once you have a building there and you have already placed all the racks, what kind of things you need then? Of course the access of the building, because there must be some admins, there must be a particular set of staff who might require access to the building or access to the data center for their day-to-day work. You need to sort out that. You need to ensure that whoever is authorized is duly checked. No one is bringing their partners or their vendors without permission, and there are due checks related to like who is going in and out, what kind of biometric mechanism we can put in place on the rack entries. You should avoid using keys for everything. You should have some kind of biometric mechanism to authenticate who is going in and out. Beside physical protection, of course, you need some kind of environmental protection as well. So all kind of fire extinguisher, all kind of protection related to maybe not having any rodent or anything inside the data center, because of course they can cut the wires. So you have to bar any kind of like food inside your data center. No one should be allowed to go in with anything beside their laptop, because all these things, they sound vague, but trust me, they are real threat because you are putting in a lot of money in that, and if you are not keeping and making that thing secure and access proof, then anyone can go in and do a lot of things inside that. So you have to bring in all kind of like data center protection related things. Environmental protection also cover your cooling facilities as well. So you have to put in cooling mechanisms because servers are quite hot when they run. They generate a lot of heat, and that heat need to be actually ventilated well, otherwise your data center temperature will rise, and with higher temperature your cost of cooling that whole data center will rise further, and that will actually impact both your data center. Your servers need to be cooled down always, and if they are generating a lot of heat, to cooling them further you need more and more power to cool them down, which is raking up a lot of money. For all that you need kind of like a good rack planning. You have to have this cold hot L based mechanism where heat from all of the server are coming into a single L, and from that L they are going outside. So you can put in a lot of mechanisms in and around that to save your cooling cost. But that's the idea. You have to, but that's also again part of environmental protection as well. And finally, regulations are always there. So if what kind of data you're storing on those server make things complicated further. So if you are storing some kind of like HIPAA compliant or PCI DSS data onto your server, then you need more advanced level of security. You might not be getting away with simply using keys or simply using a basic access to the data center, or not keeping a standby side. Each compliance or each regulations, they bring with them a further set of requirements which need to be covered if you are building your own data center. So those things need to be considered as well. What kind of data is stored on those server, what kind of applications will be running on those server. Based on that, things might go more complicated, and as a cloud architect, as a cloud security architect, you have to cover those things. You have to consider those things as well. And just now while discussing about all of these things, you might be thinking that's why people are going towards public cloud, because what you really want is save yourself from the headache of maintaining everything. Now I told you that as an end user you might not be dealing with all of these things if you're having a public cloud, but AWS or Azure is doing still the same thing. So someone somewhere had to still do those things. Again, I will say the same term. Cloud is just another fancy name of data center. It's nothing more than that. What you're doing is just accessing someone else's data center from your internet, and that's it. That's the crux. All right, what you're putting in top of your physical data center. There are a lot of things, but let's cover some of them as part of next layer of security. So hypervisor, we have discussed it again and again. What is hypervisor, what kind of thing it will provide to you, and why it need to be secure, because hypervisor is providing a virtualization layer, so it kind of have capability to talk to each virtual machine which you are building. And a vulnerable hypervisor, a hypervisor with a bug, can lead to multiple scenarios. Someone can traverse from one VM to another VM, or someone can even extract the data from the hypervisor itself, because hypervisor will be storing, or base operating system will be storing some information related to your virtual machine, because it's helping them out, right? It's quite critical component of any kind of cloud security strategy and need to be taken care of. Only way to fix is just use the most advanced hypervisors, patch it regularly, fix all the bugs, never compromise, never run a vulnerable or old operating system. Another thing which is talked really less, but it's quite important, is IPAM, which is your IP address allocation management systems. IPAM system actually keep track of what are the IPs which are allocated to different machines in your data center, in your applications. You cannot actually have same IPs allocated to different systems, which can kind of create a bad scenario where traffic will be routed to two different IPs, and then it's not good really for any application or any system owner to have same IP associated with two different systems. So IPAM system need to be there to keep a log of which system is using what IP. And of course, all the things related to identity and access management. So who is accessing, who is having admin rights of logging into your base operating system, even your guest operating system, who have admin rights, who can go in and or SSH in and do any kind of changes into your operating system, who can perform any kind of like activity, any kind of configuration inside that. Those need to be sorted out. Not anyone or everyone is allowed to access into your machine and do any kind of changes. Beside that, those images, those machine or those guest operating system need to be patched again, so they need to be always up to date without any bugs, without any vulnerabilities. If it's there, then regularly scan them them and find out more and more vulnerabilities because it's coming every day. And last but not least is security groups. So what kind of ports and protocols are allowed? Not everything should be going in and out. So if you have built a virtual machine onto your private cloud or even on public cloud, it shouldn't have like complete access of everything outside from internet to inside the machine. You must keep a check on them. Only those ports which are considered secure, for example 443 is considered secure compared to 80, you need to use 443 and only allow 443. Don't allow 80 or don't allow anything at all. Just explicitly allow those ports which should be there. That's kind of strategy which is there in public cloud. It's by default when you create a virtual machine, when you create a EC2 instance, by default everything outbound is allowed. You can access anything from inside, but anything inbound is not allowed. So no one can come into your machine unless you explicitly allow a particular port or a particular IP address or a particular source IP address. And that's the kind of strategy you should be always having. Not everything or anything should be coming inside. You need to consider what kind of ports or protocols are permitted to come in. And finally about data, because again something is being stored there, right? That's why we build that whole architecture. So who owns that data? Who you should be calling if something goes wrong with a particular data? Or what kind of things, what kind of security strategies are in place related to data? So for example, if your data needs encryption, who is doing that encryption? If you are the one who are responsible for encrypting the data, what kind of solution? Then you can decide yourself. You can think over and find the best solution to encrypt and decrypt. But if you are not doing it, if you are not owning that data, and if you're not allowed to encrypt yourself, someone have to do it, right? So you need to get hold of that team or that person, whoever is responsible for that data, and get them understand that it need to be encrypted, and discuss with them what kind of mechanism they are using, give them recommendation, what kind of encryption algorithms are up to date and are used these days, instead of using the one which are already hacked upon. So that ownership plays a key role in case of data security. We have covered a lot of things related to data security in domain 2, so it's not really worth to go everything again. But yeah, if we give kind of like a brief here, then discuss the ownership, who owns that data, and who is putting in place all the security mechanism related to data. All right, we have covered at least 2 layers of security controls or security strategies related to cloud infrastructure, and in further topics we will discuss more about coming layers which are sitting on top of base infrastructure. And of course we will discuss more on to the other topics of domain 3. Let me know if you are facing any challenges in creating ISC Square membership or getting that membership ID, and then I can help you out. Of course that membership is free and it's gonna help you guys a lot if you are starting into this field, or if you want to learn more into about cybersecurity and information security, because they share a lot of resources once you be a member. So I strongly suggest you be a member and get that membership ID at least. Yeah, just let me know if there are any issues. Beside that, I might not be recording anything for another 2 weeks, so
Menards is your home improvement destination. We've got everything you need for your projects, from ceiling to floor. Why settle for a plain ceiling when Menards carries stylish and durable ceiling tile options? Armstrong ceiling tiles offer a variety of styles that are easy to install and add a great new look to your home. Get started today at Menards and head to menards.com to check out all of the great deals going on in our weekly flyer.
Save big money at Menards.
Another 2 or 3 weeks. If not, then just don't stop your studies and keep on learning new things about cloud security. I, of course, even if not recording, I'll be studying few things related to KCNA and of course next topic of CCSP. So we'll meet after 3 weeks and I'll give you guys how KCNA went. See you, bye, goodbye, and good luck.
Thank you for listening to Get Certified Together. If you loved our content, then please like and subscribe from your favorite podcast platform so you don't miss the notification for our next episodes and announcements.